Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an isometric 3D projection of an engineering object whose front face, side view face and the top view face, they have been combined appropriately into the 3D isometric construction over here. Now with this information, we are required to evaluate the front view orthographic projections, the right hand side view orthographic projections and the top view orthographic projections of the solid over here. Now in order to evaluate the orthographic projections of the solid, we need to evaluate the dimensions of the front view face, the dimensions of the top view face and the dimensions of the right hand side view face corresponding to the solid. So as we observe the solid from the front view direction, so we observe that the width of the solid, it happens to be equal to 125 millimeter over here. Similarly, when we look at the solid from the front view, now the height of the solid, it is not provided to us directly. So now we have to look into different elements of the solid over here. So the height of the base horizontal width, it happens to be 10 millimeter. Now the height of the center of the circular hole from the top surface of this horizontal width, this happens to be 28 millimeter. So that makes it 38 millimeter from the base of the solid over here. And from the central point, now here we have got a circular arc over here having radius is equal to 25 millimeter. So this way, the height of the solid we have obtained as 28 plus 25 plus 10, that is 63 millimeter. So the front view face will be having the dimensions 125 millimeter will be the width and 63 millimeter will be the height of the solid over here. Now when we look at the solid from the top, so the width of the solid will be 125 millimeter while the depth of the solid has been provided to us as 40 millimeter. So the top view face corresponding to the solid will be having the dimensions 125 millimeter by 40 millimeter. Now when we look at the solid from the right hand side view, so we have got the dimensions of the right hand side view face as 40 millimeter, it is the depth of the solid, and 63 millimeter happens to be the height of the solid. So this way we have been able to evaluate the dimensions of the front view face, top view face and the side view face over here. So with this information, we are required to evaluate the front view, the top view and the right hand side view projections corresponding to this engineering object. Now as per the conventions of the first angle projections, the front view projections of the solid will be obtained above the XY reference line. The top view projections of the solid will be obtained below the XY reference line and the right hand side view projections corresponding to the solid will be obtained on the left side of the front view projections over here. And here we have drawn a transfer line through which the distances which will be available with us into the top view projections corresponding to the depth of the solid, so they will be transferred appropriately into the right hand side view projections over here. Now once we look at the geometry of this object, we obtain that the front view, the top view and the side view face dimensions we have been able to obtain over here. So now we have drawn two vertical projector lines which are separated by the distance 125 millimeter, which happens to be the width of the solid over here. Now these two vertical projector lines we have drawn into the front view projection area, and these two vertical projector lines we have extended them into the top view projections over here, because the width of the solid will remain same into the top view projections as well. Now we know that the height of the solid, it happens to be 63 millimeter. So now one horizontal projector line we have drawn into the front view projection area, and we have extended this horizontal projector line into the right hand side view projection, and the height of this horizontal projector line above the XY reference line happens to be 63 millimeter. So now we have been able to evaluate the front view face corresponding to the solid, which is measuring 125 millimeter width of the solid and 63 millimeter height of the solid. Now when we look at the solid from the top, so we know that the top view face, it is going to have the dimensions 125 millimeter width, which we have already obtained into the top view projection area, and now the depth of the solid happens to be 40 millimeter. So now two horizontal projector lines we have drawn appropriately into the top view projection area, which are separated by the distance equal to 40 millimeter, which happens to be the depth of the solid over here. And these two horizontal projector lines which we have drawn into the top view projections, they are appropriately transferred using this transfer line into the right hand side view projections over here. So now we can check the top view projection face. It is having the dimensions 125 millimeter width and 40 millimeter, it is the depth of the solid over here. Similarly, into the right hand side view projections, we have obtained 40 millimeter as the depth of the solid and 63 millimeter as the height of the solid. So with this, we have been able to evaluate the front view face, the top view face, and the right hand side view face corresponding to this engineering object over here. Now once we look at the geometry of this object, we can divide the solid into two parts over here. So the element number 1, it happens to be a horizontal wave which is having height or thickness, it is equal to 10 millimeter. It is equal to 125 millimeter. It is carrying two holes over here in a symmetric position. Then there is element number 2, which happens to be a vertical wave, and this vertical wave happens to have an inclined surface towards the left hand side of the solid, and it is having a circular top portion towards the right hand side portion of the solid. And into this vertical wave, there is a circular hole which is having diameter is equal to 22 millimeter, and the top circular portion which is available on the right hand side, it is having radius is equal to 25 millimeter. So let us start with the construction of orthographic projections corresponding to element number 1. So we know that element number 1 happens to be a horizontal wave having height or thickness is equal to 10 millimeter. So we have marked a horizontal projector line into the front view projections at a height of 10 millimeter from the base, and this horizontal projector line we have extended into the right hand side view projections as well. And another thing, we know that these two holes, there is one hole available into the horizontal web and there is another hole which is available into the vertical web over here. So both of these holes, they are available at a distance of 25 millimeter from the right hand side face of the solid. So now from the right hand side face of the solid, so from this point at a distance of 25 millimeter, we have marked the center line corresponding to these two holes over here, right? Corresponding to one hole in the horizontal wave, corresponding to another hole into the vertical wave. So we have marked the center line at a distance of 25 millimeter from the right hand side face of the solid. Similarly, from the left hand side face of the solid at a distance of 25 millimeter. So there is another circular hole which is available into this horizontal web over here. So we have marked this distance of 25 millimeter from the left hand side face of the solid and marked a center line at a distance of 25 millimeter from the left hand side face, and both of these center lines we have extended them appropriately into the top view projections as well. Now we know that this hole which is available into the vertical web, it is available at a distance of 28 millimeter from the top surface of the horizontal web. So here we can check that this is the top surface of the horizontal web. So from the top surface of the horizontal web, which is lying at a height of 10 millimeter from the base, so another 28 millimeter we are going to move towards the top face of the solid, and this center point will be located at a distance of 25 millimeter from the right hand side face of the solid. That is the center point corresponding to the vertical hole will be available over here. So now one center line we have drawn at a height of 38 millimeter from the base over here, and this horizontal center line we have appropriately extended it into the right hand side view projections over here. So now since we have been able to locate the center point corresponding to a hole which is having diameter is equal to 22 millimeter into the vertical web, so we have drawn a circular hole projections into the front view projections which are having diameter is equal to 22 millimeter, originating from this central point which we have already marked into the front view projections over here. And another thing we can observe over here, there is a top circular arc which is available at a radius of 25 millimeter, originating from the same central axis point over here. So this central axis point we have already located. Now we can check this horizontal distance is also 25 and this vertical distance is also 25. So with this as center point, this radius of the arc equal to 25 we have marked over here through this center point. So now we have been able to obtain the top right hand side circular portion corresponding to this vertical web over here. So now we know that corresponding to element number 1, we will be able to visualize the rectangular projections into the front view projection such that the height of the front face of the horizontal web, this will be equal to 10 millimeter, and the width of the horizontal web, this will be equal to 125 millimeter over here. So the projections corresponding to element number 1 they have been obtained, and now corresponding to the circular portion we know that there is a vertical face which is available onto the right hand side face of this particular solid. So this vertical web will be having a perpendicular face towards the right hand side surface of the solid over here. So now we have obtained the vertical projections corresponding to this vertical face of the vertical edge over here. Now another thing we know that this circular portion has been appropriately joined towards the left hand side at a point which is lying at the top surface of this horizontal web onto the left hand side over here. So from this point we have drawn an inclined projection corresponding to this inclined surface, and we have observed that at the left hand side, so this inclined surface is going to meet with the top surface of this horizontal element of this horizontal web element number 1 over here. So now we have been able to obtain projections corresponding to element number 2 over here. Now corresponding to element number 1, another parameter now we need to focus upon, there are two circular holes over here having diameter equal to 10 millimeter. Both of these holes, they are located in such a way that the center of the hole will be lying at a distance of 25 millimeter either from the left hand side face or from the right hand side face over here. So from these two center lines, now we are going to mark 5 millimeter offset on either side, so that the diameter of the hole which we are going to obtain into the horizontal wave, it should be equal to 10 millimeter over here. So now two projector lines we have drawn corresponding to hole number 1 into the element number 1, and another two vertical projector lines we have drawn corresponding to hole number 2, which is having diameter is equal to 10 millimeter. But both of these holes, they will not be visible to the observer, as the observer is going to look at the solid from the front side. So we are going to obtain the hidden line projections into the element number 1 in the front view projections over here. So this way we have been able to obtain the front view orthographic projections corresponding to this engineering object. Let us now evaluate the top view projections corresponding to this object. Now we know that into the top view projections, whenever the observer is going to look at this object from the top direction, we know that the depth of this vertical wave, it happens to be equal to 12.5 millimeter. And another thing, we know that this vertical wave, it happens to lie towards the rear surface of the solid over here. So this is the rear surface of the solid, this is the front surface of the solid. So onto the rear side of the solid, we have measured a distance of 12.5 millimeter corresponding to the depth of this web over here, and we have drawn a horizontal projector line at a distance of 12.5 millimeter from the rear surface. And this horizontal projector line we have appropriately transferred into the right hand side view projections over here using this transfer line. Now we can see that having marked the depth of the wave, we know that there is a circular hole which is lying into this vertical wave, and the diameter of this hole we have marked as 22 millimeter. So we have already obtained the front view projections corresponding to the circular hole in the vertical wave. So now from these 2 points of the diameter of the circular hole, we have drawn two vertical projector lines into the top view projections over here, so that we can define the boundary of the circular hole over here. So now we can check when we are going to look at the solid from the top. So this total surface of the vertical wave, even though it is an inclined and a circular surface, it will be appearing as a rectangular web into the top view projections over here. So this top view projection corresponding to the vertical wave, it is an apparent shape representation of the vertical wave into the top view projections over here. So it is no longer a true shape projection, because this surface is an inclined one, and this portion of the surface towards the right hand side of the solid, it happens to be a circular portion over here. So since this web, it is not parallel to the horizontal plane, so its projection on horizontal plane, that is the top view projections, they will be projected as apparent view projections into the top view projection over here. And another thing we know, corresponding to this portion of the horizontal wave, so since this portion of the horizontal wave, it happens to be parallel to the horizontal plane, so we have been able to obtain the true shape projections corresponding to this surface of element number 1 over here, or the horizontal web over here. So now we can see that this circular hole, which is having diameter is equal to 22 millimeter, it is not visible to the observer from the top. So we are able to obtain the hidden line projections corresponding to the circular hole into the top view projections over here. Now there are two more holes which are existing into this component, into element number 1 over here, which happens to be a horizontal wave. So into the horizontal wave, we know that at a distance of 12.5 millimeter from the front face, this is the front face of the solid. So at a distance of 12.5 millimeter from the front face, there are two holes which we are required to locate. So now we can check we have marked a distance of 12.5 millimeter from the front face, and a center line we have drawn corresponding to these two holes into the top view projections, and the center line has been appropriately transferred once again into the right hand side view projection view over here. So now the center point number 1 and the center point number 2 corresponding to these holes we have been able to locate, and we know that the diameter of the hole is equal to 10 millimeter. So now with this as center and with this as center, we have marked two holes into the top view projections having diameter is equal to 10 millimeter. So with this, we have been able to complete the top view projections corresponding to this engineering object. Now let us focus on to the right hand side view projections corresponding to this object. As the observer is going to look at this object from the right hand side, so we know that one rectangular projections corresponding to the horizontal web will be visible to the observers. One rectangular projections corresponding to the vertical portion of the web, it will be visible to the observer from the right hand side. So now we can see that we are going to obtain one horizontal rectangular projection over here which is lying at the base of the solid corresponding to this horizontal web. Then another rectangular projection we are able to obtain which is lying onto the rear side of the solid corresponding to the vertical web, and this vertical web is going to have the depth is equal to 12.5 millimeter. We can check this out. This depth happens to be 12.5 millimeter over here. So now we know that we have already obtained the location of these two holes over here into the top view projection which is having diameter is equal to 10 millimeter. So from these two extreme diameter points corresponding to these two holes, now we have drawn two horizontal projector lines into the top view projections, and we have transferred these two horizontal projector lines corresponding to these two circular holes into element number 1 into the right hand side view projections over here. So since this hole is existing into the element number 1 which is the horizontal web, so we haven't extended these two projector lines up to the top face of the solid over here. So now we know that if we are going to look at these two holes from the right hand side view position, so hole number 1 and the hole number 2, they are going to overlap with each other into the side view projection, and further these two holes they will be covered by this surface of the horizontal web, so they will not be visible to the observer from the right hand side view projections over here. So now we are going to obtain dotted line or the hidden line projections into the right hand side view corresponding to this hole which is going to have the diameter is equal to 10 millimeter. So this distance we can check out. This distance is equal to 10 millimeter which we have already marked appropriately into the top view projections over here. Now another thing we can observe, the vertical web, it is also carrying a circular hole over here which is having diameter is equal to 22 millimeter. But once again, this hole, it is not visible to the observer because this hole has been covered by this portion of the solid over here. So once again, we are going to obtain hidden line or the dotted line projections into the right hand side view projection view over here. Now corresponding to this hole which we have already obtained into the front view projections, two horizontal projector lines we have extended into the right hand side view projections over here corresponding to this diameter extreme points of this circular hole over here. So from these 2 points of the diameter, we have drawn two horizontal projector lines into the right hand side view projection area, and wherever these two projection lines, they will be passing through this vertical wave. So the location of this circular hole into the right hand side view projection area we have been able to locate. And now since we are not able to visualize this hole directly, so we have been able to obtain the hidden line projections corresponding to this hole, which is having diameter is equal to 22 millimeter. So this way we have been able to obtain the orthographic front view projections, orthographic top view projections, and the orthographic right hand side view projections corresponding to an engineering object whose 3D isometric projections they were available with us. So I hope that through this discussion you would have understood about the procedure to convert the 3D isometric projections into multiple 2D orthographic projections over here. So this is all for today. So we will be continuing with further discussion regarding few more illustrative examples of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.